Yeah, welcome to this next class. In the previous class, we have discussed about linked list. What is linked list and how to create a linked list and how to display all the elements in the linked list. So that we have discussed detailedly in the previous class. In today's class, we can discuss about how to insert a node in the existing linked list and how to delete a node from the existing linked list. So that we are going to discuss today's class. So already you all know what is linked list. So the linked list, each and every element is stored into one node. So the node is nothing but it contains the two field. One is data, other one is next field. The data is nothing but it will holds a value. Next is holds the address of the next node. So you all know this. So how to implement this node in the programming? Using the structure concept, we can implement this node structure. So using the C language structure, we can create a structure for this node. So you all know the syntax for the structure. So struct node. Okay, inside that structure, it has two members. One is data and other one is pointer. So first you have to create a structure. So this will gives only the structure of the node, not the memory. To create a memory of this node, we need to use the dynamic memory. So generally the dynamic memory is implemented using the pointer concept. So now we are allocating the memory for this node using the malloc function. So, okay, and all after creation of the memory for the new node, then we have to assign the new node next pointer is always null. So up to this we have discussed in the previous video. So now we will discuss the insert operation. Okay. So in this class we are going to discuss only the logic of the insertion. How to insert the node at the beginning, how to insert the node at end. We are not going to discuss the entire code. So that we have discussed in the discussed already in the previous class. So now we will discuss what is insert operation. So insert operation is nothing but, so already the list contains some values. Here is not a list, it is a linked list. So linked list contains some nodes are available. Now we are going to add a new node into the existing linked list. So that is called as insert operation, adding a new element to the already existing linked list. So that is called as insert operation. Here in linked list we have three type of insert operation: insert at beginning, insert at end, and then insert at any position. Now we will discuss what is insert at beginning. So this is the sample diagrammatic diagram. So here the list contains the two node. This is one node and this is the second node. So you all know always one node address is available in the previous node. This is the first node of linked list means definitely the address of this first node is available in the head pointer. Likewise, the second node is address is available in the first node. So this is the features of linked list. Now we are attempting to insert a new node in the first. Already this is our existing list. So the head is connected with the first node. Now we have created one new node using the structure concept as well as memory is created using the dynamic memory malloc function. Once the memory is created, this new node have some address, and from the user we can collect the data for this new node also. So this process is done. We have some new node so created. Now we are going to insert this new node at a first position. So already in the first position, so this node is available. This is the old link, because this, for example, we can take the address of this node is 100 and this node is 200. So this 100 will be available in the head and this 200 is available in this first node. This is the logic of linked list. Okay, now how to connect this new node as a first node? So the header contains the address of the first node. Okay, if we are transferring the address of head equal to, okay, this new node means, so this will be connected, then this new node address we can given to head means this will be connected. So these are the two links we have to take care. The first link, already head contains the address of first node. Okay, for example, this is 100 and our new node address is 300. So head contain the address 100, so that we can given to the new node. Initially, the new node next field is null. Okay, usually the once we have created a new node means the new node data, okay, data field contains some element. but the next field always empty or null. So now we are going to assign this head value. Head value contains, head pointer contains 100. So that 100 is given to this new node. So this empty is replaced by this 100. Once we have assigned this head pointer value to the new node pointer means, so these two nodes will be automatically connected. This link will be created. Now we have to give some value for this head pointer. So already the head pointer also having a value of 100. Now this 100 also transferred to this new node pointer. So in both the places we have 100. So this 101 is a valid now. So now we can replace this 100 with this new node address. So this new node address is 400. So that 400 is given to head means these two node will be connected. So this is the logic for creation of or insert at the beginning. After creation of new node, so this new node is inserted at the beginning position. So this is logic. So head address is given to new node next, as well as new node address is given to the head. So this is simple logic. The same we have written as a coding. So here the head contains some value 100. So that is assigned to the new node next. Initially the new node next is null. Then once the 100 is assigned to the new node next, this field, then we can assign the new node address to the head. So this new node address is 400. It is given to the head. So these two will be connected. So this is called as insert at beginning position. So next we will discuss insert at the, wait, I will just move my screen here. Yeah. So now we will discuss insert at end position. So this is a diagrammatic representation. First we will discuss insert at the end position. So insert at end position means we have to traverse to the end of the list. Then only we can insert the new node at the end position. So how we can traverse to the list? Already we have discussed in the previous class. To traverse the list, either we can move the head pointer or temporary pointer. If you are because always this head pointer is a fixed one, we cannot move this pointer to access the linked list. So to instead of moving this head pointer, we are going to use the temporary pointer. So this head is assigned as temp. This head value is assigned to the some head. So okay, this head is assigned to some temporary address, temporary pointer. So that pointer we are going to move from first node to end of the linked list, because we want to insert the value at the insert the new node at the end position. So we have to traverse to the end. So for that we are creating one temporary pointer, head equal to temp. So this head is contains some address. We can say this 5 is 100, 9 is 200, 23 is 300, and 45 is a newly created node that address is 400. So this 400 is we are going to assign. Okay, here at the end position. So for that, so first head address 100 is available here. So that 100 is assigned to another one pointer, temporary pointer. So head equal to temp means, so the temp also contains its address of head. Now we are going to move the temp pointer to the end position. So for that we are using the while loop. So while temp next is not equal to null or not. This is the temp next, it holds the address 100. So the 100 means this is a node 100. We can check whether this node is not a null or not. Yes, it is not a null node because it contains the element 5. So if the condition is true, we can move the pointer to the next position. Temp next equal to now called as temp. So now this is a temp next position. So this is a temporary node temp data, and this will be accessed via programming. This will be called as temp data. This field is called as temp next. Now this is a temp next. So the temp next holds the address of this 9, that is 200. So now this 200 is called as a temp now. Again we can check the condition whether this temp next is not equal to null. So this 200 is null or not. Yes, it is not a null. Again we can move a pointer to the next position. So likewise we can keep on move the temp pointer. So once we reach this node, we can check the condition of temp next is not equal to null. So at this time it will not show the true condition of while, because here the temp next is null. So we can stop the pointer, it will not enter, okay, the accessing, we will not move further because it will stop, because the while loop condition is false, so it will not further enter into the loop. So once we reach this position, so this is our temporary node now. Then insert at beginning means first you have to create a new node. As usual, you have to create a structure of your node, and then you, after creation of structure, you have to create a memory for your new node. Then you have to collect the value of data for the new node, and always the new node next field is null. So up to this process is common for all the insertion. Then we have to insert this node as a end position. So now we found the end position, that is temporary pointer is the last node. So the temp is available, so that node is called as a last node. After that we are going to insert that new node. So now here the temporary next, this is a temporary node. Here in this diagram it is given as a previous node, but it is not a previous, it is called as a temporary node. We have moved the pointer. So this node is called as a temporary node. So this temp node next field, this is called as next field, initially null. And if you want to insert any value means, if we have assigned some value means, this will be automatically connected. Okay, generally if this is a new node, so this address we have to forward to this temporary next means automatically these two will be connected. So this is empty, and we know the address of new node, that is 400, so that we can assign. So new node equal to temp next. So that's why here the logic is new node equal to temp next. So this 400 is given to this. Now automatically this temp and new node will be connected. Then we have to assign the pointer of new node next. So this is a new node next. This is by default is empty only. So that also we have to define here. So new node next equal to null. So this is the logic for insertion at the end. For inserting element at the end position, okay, first you have to move the pointer. We cannot move the head pointer because it's a fixed one. So we are creating one alias pointer for the head. So that is called as a temp node or temporary pointer. So that pointer we are moving from first position to last position using the while condition. Once we reach the last position of our linked list, we can insert the value at this end position. So this is a temporary node. So this temporary node next field is null or empty. So in this place, we can give some address means automatically this node will be connected with the new node. Usually the feature about the linked list is always one node address is available in the previous node. Now this is our new node. We can say this temporary node is called as a previous node for this new node means we have to give the address of this new node to in this temp next field. So that's why here the logic is new node equal to temp next means this 400 addresses assigned to temp next. So these two nodes will be connected, and this new node next field is null. So this is about insertion at the end position. Now, now we can discuss next insert at the any position. Yeah. So next, the third condition of insertion is insert at any position. So for that, you have to collect a value from the user. At what position user wants to insert the new node. So that position you have to collect from the user. For that, get a printf statement, enter the position, and get the position using scanf. Okay, get the value of that position using scanf. Then we need some I pointer. So that is I value. So that will be initialized as 1. Next, you have to some compare some precaution condition. So here position is greater than count. Here the count is nothing but how many number of elements are available in the existing linked list. So already we have a list that contain the three elements means that count is 3. So always we have to take a position lesser than that count. So if the position is within that count only, we can insert the value at the middle. If the position is greater than the count means we cannot insert, so that position is not a valid. So that we have to check here. If position is okay, for example here I'm taking the position is this 1. After the one okay first node, I'm going to insert a next value. So for that I'm collecting the position as 1. Okay, here the position is 1, count is here, the totally two nodes are available, so the count is 2. So 1 greater than count is 2, so the condition is okay. Yes, it is false. It is not a greater. Position is 1 and count is 2. The condition, if the condition is false, so it is not a invalid position. So it is a valid one. So this position is a valid one. So now we go for the else case. So here the else. Okay, because we got a position that is lesser than the count. So now we can take a else part. So in this else part, as usual, we have to reach this position. How we can okay reach this position? through the temporary pointer. So through some other pointer only we can move to the respective position. We cannot move the head pointer. It's a fixed always. So we can assign head equal to temp. So now this is called as a temp. So we can move the pointer, a temp pointer to reach that position. So you have to check the condition. While I less than position, I is 1, position is 2. 1 less than 2. Yes, the condition is true. We can move the pointer of temp equal to temp next. Initially the temp is 100. So that will be moved to here. The temp next is this value 200. So now this is a temp. Okay. So here the temp pointer is reached here. In case, in this example, I have taken the linked list with the 2 node, but we can take the linked list with the 10 node. Already in the we have a linked list with the 10 node is available, means we can take a fifth position. To reach the fifth position, we need 5 iteration of while loop. Okay, to reach that particular position. But in this example, only one iteration to reach the position, because we have only the 2 node. Okay, so to reach the first position, only one iteration. So for that, here the while loop is not iterated much time, because at the first node itself we got a position. So this is our position. So now we are going to insert the value. In for example, we have a list with the 10 nodes. I have selected the position as 5, means I have to travel to the fifth position. So 5 times the loop will be iterated. And then for every iteration, we have to move the pointer temp equal to temp next equal to temp. Likewise, you have to found the position. We have to move the temp pointer until you found the position. So that is for the largest collection of linked list. But in our case, here it contains only the 2 node. So if the first position itself, we got a first node itself, we got a position. So once we found the position, now I am going to insert the value after this position. After this one node, I am going to insert a new node. As usual, the procedure for creation of new node, you have to create a node structure, then you have to create a memory in the dynamic memory, and then you have to get a value from the user, the data field of this new node. And now we are going to insert this node. This is a old link of this temporary node and then this node connection. Now we have to remove this old link. Instead of this one link, we have to make a two connection now. So how we can connect this temporary node, this here some address. So this node address, for example, this node address is 100, that is available in the head. This node address is 200, that is available in the temporary node. So here 200. So this 200, okay, initially this node address is 100 and this node address is 200. So this okay, this node address available in the head pointer. Always the linked list feature is every node address will be available in the previous node. So this node address is available in this previous head. So this node is address is available in the temp. So this is the old structure of our linked list. This is a old structure. Now we are going to insert the new node in between these two nodes. For that, here this node address 200 is holded by this temporary node next field. Now this address we can move to this new node next. So this will be accessed new node data, and this field is called as new node next. This new node next is empty initially. So we can transfer this 200 to this location, means this 2 will be connected. So this is over. Now this is empty, not empty. So the same copy is available here. We can replace this value. So how we can replace? We want to connect the new node with this. So for that, the new node address is 300, means that 300 is given here. So new node equal to temp next. So these two will be connected. So this is called as insertion at the any position. So first, once you identify the position, then you have to create a new node and then connect the temp node next equal to new node next. So this is empty, so we can assign the temp node next equal to here. Then once you have assigned this temp node next to this field, then we can give the address of new node equal to temp. That's why here new node equal to temp next. So now both will be connected. So this is called as insertion at any position. Okay, I hope you all understand how to insert at beginning and how to insert at end position and how to insert a node at any position. Now we will discuss the deletion operation. What is deletion operation? So deletion operation is nothing but removing some element from the existing list. So that is called as deletion. Insertion means adding some element to the or adding some node to the existing linked list, that is insertion. Deletion means deleting or removing some value from the existing linked list. So that is the deletion. So like insertion, deletion also we have three type: deletion at beginning, deletion at end, and deletion at any position. Now we will check with the deletion at beginning case. Okay, so now this is our old link. Okay, so this is our linked list. The linked list contain the three nodes 1 and 2 and 3. So this first node address is available in the head, and this second node address is available in this first node, and third node address is available in the second node. So this is our old structure. Now we are going to delete the node at the beginning position. Now I want to delete this node. How I can delete? Because this node address is available in the head pointer. Okay, directly I cannot delete this node. If I deleted this node means this head is disconnected, as well as the second node also had disconnected. Okay, if I have attempted this, okay, attempting to delete this node means once I have deleted this node, so this node will be detached from the list, because the address of second node is available in this first node. If I have deleted the first node means that the second node will be detached, the whole continuity will be uh, gone. So to avoid that, first we have to make a continuity first, then we can free this node. For that, this head is contain the address of first node. I want to delete the first node. So no need to retain the address of first node in the head. So I can replace this head value with the second node. So this is the second node. So head node, this will be called as head node next. So this is a head pointer, this is a head pointer data, and this is the head node next. So this head node next is given to the head now. So head node next equal to head means these two will be connected now. Okay, and we have a continuity among the existing nodes. So now this first node is free. Now we can delete easily. So this is the logic now. Okay, so delete from the beginning one function we can take. Then you can create a one temporary pointer struct of node asterisk temporary pointer, and assign this temporary pointer head equal to temp. Then head next. Okay, head next equal to here, this is a head, and head next is called as now head. So this address here 100, and here 200, 300. Now 300 is initially head is holding a head pointer hold the address is 100. So through that only these two node will be connected. So now I don't want this connection. So for that I am just moving a head node next address. This is a head node next address. It value is 200. That I am going to assign here. So once I have assigned this, these two will be connected. Now this is free. Okay, I can easily delete that. So next is head equal to head next. I cannot delete the free of head. So already I have assigned this head value, head is equal to 100. So the head is equal to 100 is assigned as a temp. Wait a minute. Okay. So here, this head node address, this is the head. Okay, this head is already I have take a copy of head into the temporary node. So this is the temporary node. So this temporary node contains the first node address. So now this head contains the second node address. So the continuity of the link is available. So but I need to delete this node. So I am just going to free up the temporary pointer, not a head pointer, because I have a head pointer is replaced replaced with the head next. So head contains now a new value, but temp only contains a value of this 100. So we need to delete this node means you just free up the memory of pointer address of this free temporary node. That's why here free of temp. So once you have deleted a node, you have to free that memory in the dynamic memory. So already we have discussed in the dynamic memory concept. So once after your task is done, you have to free the memory in the computer, because the memory is a crucial resource of a computer. So we have to utilize properly. So after the deletion of this node, we have to free this temporary pointer. So this is called as deletion at the beginning position. So next we can take the deletion at end position. So deletion at end means, for example, this is a diagram. Okay, wait a minute. Mm. So this is the diagram, and this diagram so totally contain the three node. I'm going to delete the last node. So how I can delete the last node? Directly I cannot delete the identify the last node and then I cannot delete, because the linked list it is a sequential access only possible. So to get a last node, I have to traverse from the first of the linked list, and then I have to go with one by one only. I can reach the end position. So how to reach that end position? Even the same case we have discussed at the insertion at end. To insert a node at the end position, first you have to traverse the list from the starting to that particular end position, end of the list. Then only we can insert a new node. Likewise, here we are going to delete the node, not the insertion. So we no need to travel at the end position, end of the list, because we are attempting to delete the end node only. So we have to move a pointer before the end node. Okay, so the previous pointer. So we need a previous location of the deleted node. Then only we can delete the end node. So for that, you are creating a next one new pointer, so that is called as a previous node pointer. So in the previously we will use this only one pointer, that is temporary pointer, that is used for accessing the linked list nodes. Now I need a previous node. If I want to delete one node means I need to find the previous node first. Why I need to find the previous node means all the nodes addresses are available in the previous node only, because if I want to delete one node means I have to remove the address of that node. How I can remove that address? Where that address is available, it is always available in the previous node. For example, this is my deleted node, this address is available in the previous, and this node address is available in the previous. I want to delete this node means I have to delete the address of this node. So this address is available in the previous node. So that's why I have used another pointer, that is previous node. As usual, you can assign the one alias pointer for the head node, that is temporary node. You can go with the position of find the previous node. Okay, for next you have to check the while condition. So temp next is not equal to null or not. This is initially temp. So this temp next is called as one node. This is not a null node. So you can move the pointer to the next position. Yes, the temp is moved to now here. The temp is now is also a not null. Okay, and this is also okay. Next we have to reach the end position. So now this is end of the list means the end of list next field is always null. So now you can check the condition, temp next is null or not. Yes, here the temp next is null, so it will stop here, the pointer is stop here. Now this is called as a temporary pointer. Now the temp pointer pointing this last node of the linked list. After that, it will not enter into the linked list. So next, once we reaches the last node, then we have to check the condition. If the temporary node is equal to head, there is no nodes are available, so we can easily assign the null to the head. There is no values are available. If the temp and both heads, okay, if the temp and head are equal, after accessing this, if both are head and temp and heads are equal, means there is no data are available in the linked list, we cannot do the deletion operation. For that, we are checking this condition. So yes, here in this case, there is no head and temp are not equal. After the traversal, the head temp is pointing this address and head is holding the address of this node. Both are not equal. So go with the else case. Now we are going to give the previous node. The previous next equal to null. So okay, once you identify this node, you have to mark the previous node for this deleted node. So the deleted node, this previous position is this one. For that, we can say, okay, this is the last node temp pointer. Here, this node is called as a previous node. Okay, so this is temp next, and then this temp is called as a previous one. Once we are moving the pointer of temp to here, means you have to make this as a previous node. You have to okay, you have to include one more statement. This okay, temp equal to previous node. Once you identify the position of a temp node, whether it is not a null node, means you have to name that node as a previous node. Then you have to move a pointer to this. This is also not a null node, means you have to move a pointer to temp node to here. Again, this node will be called as a previous node. We have to name this node, yeah. So here you have to move. Okay, name this node as a previous node equal to temp. Okay, so now this is the previous node and this is the temp node, and now we are going to delete the node. So we got a position of our deleted node, as well as we got a previous node of our deleted node. This is my deleted node, and I got the previous node also, because in previous node only my deleted node address is available. That's why I found the position of previous also. After that, you just make a previous node next is equal to null. Initially, this is my previous node. The previous node next field holds the address of my deleted node. Now I want I want to delete this node, means just you can make this as a null. So now for that, here the programming is previous next equal to null, means automatically this will be disconnected, and now this is a temporary node. Once it is disconnected, you can free this temporary node. So this is the deletion at end position. So delete at the end position. So you have to traverse the list one by one from starting portion to end of the list. Once you reach